Hi, this is Miss Fox. I'm here to teach you about complete and net ionic equations. We started talking about this before, but I just wanted to go back over it since we haven't been at school for a few days. And so I hope everybody is safe and staying well. And now we're going to start talking about complete and net ionic equations. Well, as we have talked about before, chemical reactions take place most of the time in aqueous solutions, but not everything supports a chemical reaction in solution. For example, if I have an ionic compound that is in a water solution, then what happens is the ions are broken apart off of the table salt. For example, if this is sodium chloride, the sodium ions are separated from the chloride ions in this crystal. And so each of the ions is surrounded by water molecules until all of this sodium chloride goes away. But covalent or molecular compounds do not break up or dissociate when they dissolve in water. So this sugar molecule that's probably right here is still kind of all together. So remember that only ionic compounds dissociate into ions when they are in solution. All right, so we need to talk about what a solution is so we can talk about what happens. Number of different things happen in solution. So first of all, to make a solution, you need a solute, the substance being dissolved, and then you need a solvent, the substance doing the dissolving. The solute is dissolved in the solvent. Most of the time in chemistry, we use water as the solvent, and it's considered the universal solvent because many substances will dissolve in water. And when they dissolve in water, they dissociate. In a chemical reaction, when you see a chemical written over the arrow, it is not taking place in the reaction, but rather is added to the reaction. So this first dissociation equation shows that sodium chloride is dissolved in the water to produce sodium ions, and they are still in aqueous solution, and chloride ions, also in aqueous solution. So each unit of sodium chloride will give us 2 ions in solution. We could also say this another way. We could say that if we had 1 mole of sodium chloride, that would be equal to 1 mole of sodium ions and 1 mole of chloride ions. If we have a different kind of ratio in a compound, an ionic compound, such as calcium chloride, there is a 1:2 ratio of calcium to chloride ions. When dissolved in water, you get 1 calcium 2 plus ion for every 2 chloride ions, and chloride is a 1 minus. So you get 3 ions in solution, 1 calcium, 2 chloride. Another way to say this is that a mole of calcium chloride is equal to a mole of calcium ions and 2 moles of chloride ions. Okay, so in a double replacement reaction, so if you put 2 ionic compounds together in the same reaction vessel, for example, this test tube, they can react to form what's called a precipitate. A precipitate is a solid compound that forms when you put 2 aqueous solutions together. But you must consult solubility rules to find out the precipitate. So I've got a link in this presentation where you can go directly to the solubility rules, and you'll recall that you have these in your notes, or you should. Another thing that you might see sometimes is what's called a solubility table. But you consult these rules to determine what will stay dissolved in a solution and what comes out as a solid. So looking at these compounds, we have potassium nitrate, magnesium sulfate. Magnesium and potassium switch places, double replacement. So when potassium forms a compound with sulfate, we need 2 potassiums because each of them is a +1, the sulfate's a -2. Magnesium is a +2, nitrate is a -1, so we need a 1:2 ratio of magnesium to nitrate. So to determine what the physical states are, looking at those solubility rules, all potassium compounds are soluble and all nitrate compounds are soluble. So looking at these rules, number 1, all nitrate compounds are soluble. Rule 2, all sodium and potassium compounds are soluble. So that's important. Okay, so once you've determined that they're both soluble, then you know right off that the reaction did not occur if you did not get a precipitate. Or if you get bubbles, a reaction occurred, but you might not get a precipitate. Those are usually acid-base reactions, which work kind of like a double replacement reaction. But this one does not include an acid and a base, and we did not get a solid product, so no reaction occurred. So you notice that sometimes when we did that lab, you didn't get a reaction. That's why. Okay, so let's go through predicting the products. If you start with barium and chloride, sodium and sulfate, and we're going to go through how to write a complete ionic and a net ionic equation. But first, we're going to predict the products. Okay, so you know that your outside ions go together and your inside ions go together. But you look at the ionic charges to figure out how they go together. So when you switch the positive ions, barium and sodium, when you put barium with sulfate, then you just have a 1-to-1 ratio. So you do not need any subscripts for those. Also, sodium, although it has a 2 subscript on the left side of the arrow, on the right side of the arrow, when we put it with chloride, we don't need a subscript because we have to make those charges equal 0. Just like when we learned to write formulas for ionic compounds. So the products are BaSO4, which is barium sulfate, and sodium chloride, NaCl. Now you use the solubility rules to determine the physical states of your products. Well, if you look back at your solubility rules, you'll notice that most sulfates are soluble except for barium sulfate. Okay, so if it's an exception, that's going to be a solid. Then if you have NaCl, the other rule is all sodium compounds are soluble. If it's soluble, then it dissolves in aqueous solution. Whoops. Okay, so here's what you would have. Solid and AQ. I always have a lot of tabs open. All right, so here's what would actually happen in that reaction, and I'll just hit play on this. It's about, I don't know, a minute long or something, if I can make it work.
In the double displacement reaction of barium chloride and sodium sulfate, we start out with a colorless solution of sodium sulfate. When we add barium chloride to it, we get the rapid formation of a white precipitate of barium sulfate.
Okay, so we determined that barium sulfate is the solid because all sodium compounds are soluble, so it can't be this sodium compound. And then all sulfate compounds are soluble except for barium sulfate was listed as insoluble. So that's the solid precipitate. Okay, to write a complete ionic equation, we show all of the ions in aqueous solution and the solid product, which is called the precipitate. For a net ionic equation, it shows only the ions involved in forming the solid product, which is the precipitate, and do not include spectator ions. The spectator ions are the ions that stay in solution. So the solution is aqueous and they don't participate in making the solid, so they are spectators. Okay, complete and net ionic equation for this reaction that we just did. We start with the balanced equation. We did have to put a 2 in front of NaCl to balance the Na and the Cl on the left side. So I don't know if I said that before. All right, now you'll use subscripts and you'll use coefficients to tell how many of each ion that you have. So you start with one barium ion, Ba2+. Remember, AQ for all ions on the left side of the equation. There's 2 Cl's, you put it as a coefficient, 2 Cl 1 minus AQ. There's Na2SO4, so there's 2 sodium ions, AQ. 1 sulfate ion, that's a unit, minus 2 polyatomic ion. Product is BaSO4 solid. When they are solid, we do not separate into Ba and SO4 because it's not dissolved anymore, and it can only be aqueous if it's dissolved in the water. So that one stays all together. Then we have on the right side 2 sodium ions and 2 times the chloride ion there, so 2 chloride ions. And how do you figure out what to do to mark out certain ions? Well, you mark out the ions not involved in forming the solid. So what's in the solid? Barium and sulfate. So mark out everything on the left side and on the right side that's not involved in forming BaSO4. So it would look like this. The Ba stays, AQ. Mark out the 2 Cl's, the 2 Nas. Keep the SO4 minus 2, AQ. The product is BaSO4 solid. Once you have marked out the spectator ions, the ones that are just watching and not participating in making the solid, then you write just the net ionic equation, which would include just the ions and the solid that form from those ions. Barium is a 2 plus, AQ. Sulfate is 2 minus, AQ. The product is BaSO4 solid. Okay, so here's the summary sheet. If you don't have these notes, stop right now, pause the video, and go ahead and make sure that you write all of this down for your notes if you don't have it. Okay, next slide. I want you to write this down. I'm going to give you a minute. You can pause it at this point, and then I'm going to ask you to pause it before you look at the answers. Okay, here's the answers to the practice. The complete ionic equation, Mg2 plus, 2 NO3s, 1 minus, both AQ. It is important to write those AQs. 2 Na, 1 plus AQ. CrO4, 2 minus AQ. Product, nitrate compounds are soluble and sodium. So the first compound would be an aqueous solution, 2 Na, 1 plus AQ, 2 NO3, 1 minus AQ. And the second product is going to be your solid, magnesium chromate solid. Mg2 plus AQ plus CrO4 2 minus, MgCrO4 solid. We marked everything out that was not involved in forming that solid. Okay, if you need more information about this, I will post this slideshow as well for you to go ahead and go back through it at your leisure. You can watch my video again. You can watch this video. This is Melissa Maribel, or you can just look for it, Net Ionic Equations, and it's Melissa Maribel. All right, and make some good notes about this. You do need to understand net ionic equations if you do plan to take further chemistry classes.